Ladies and gentlemen, we're talking about aspect ratios. We're going to continue with some extension questions. This video helps to demonstrate how aspect ratios affect things other than television size. So when changing the size of a rectangular image using computer drawing program, how can you maintain the same aspect ratio? We're going to investigate this scenario with computer applications. So the first thing here, we have the width, which looks to be an 8 in centimeters, and we can divide that 8 by 2 and also divide the height by 2 and get an aspect ratio, very similar picture, just on a smaller scale. So it's exact same aspect ratio, just on a smaller scale. And so there's the demonstration that includes the height being divided by 2 as well. Also, we can take the diagonal of a rectangle, and as long as we shrink the image along the same diagonal, then we'll have the same aspect ratio. So here's a picture, and you should be able to see the diagonal of this picture, and then you'll notice when we shrink the picture, the diagonal is on the same line as the diagonal of the original picture. So these two images have the same aspect ratio. So if we look at question 6 here, today most theaters have aspect ratios of 1.85 to 1 or 2.35 to 1, and the widescreen television is 16 to 9, and the old full screen television is 4 to 3. So what we have to do is we have to see how big the letterbox images are. Here a 50-inch 16 by 9 television with an aspect ratio image of 1.85 to 1. And then the second one we'll do is an aspect ratio image of 2.35 to 1 on an older full screen television 4 by 3 where aspect ratio is 25 inch. Find the height of each black bar on the top and the bottom of the screen. So the first thing that we're going to do is we are going to calculate the area and calculate the dimensions based on what we have here. So you should remember from earlier that that K is equal to the diagonal of the screen divided by the diagonal of the aspect ratio. Well, you should remember the 16 by 9 aspect ratio is a square root of 337. That's going to give us K equals approximately 2.72. So then we can find the height and the width. So the width is equal to 16 times 2.72, and the height is equal to 9 times 2.72. So that gives us a width and a height of 43.5 inches to 24.5 inches. Now we need to calculate the aspect ratio and convert it to the ratio of 43.5 to 24.5. So we will take 43.5 and divide it by 1.85. So we can see what the second dimension, the height dimension, is going to be for the image. So here we get that the height of the image that has a 1.85 to 1 ratio is approximately 23.5 inches. Now our TV screen is 43.5 to 24.5, and our aspect ratio for the image is 43.5 to 23.5. Now you should be able to see that there is a difference here of 1. So when we subtract these, we get a 1 inch. Well, since there are black bars on top of the image and at the bottom of the image, that means there are 2 black bars, which means the black bars, they each have a height of 0.5 inches, which makes them very small at the top and the bottom of the screen, filling the screen very nicely. We'll do very similar thing here with the next problem. So here we have a 25-inch television screen divided by the diagonal of the aspect ratio triangle. So that's a 3, 4, 5 triangle. So our K is equal to 5, which means our width is 4 times 5 and our height is 3 times 5, which give us 20 for the width and 15 for the height. So if we do the same thing with the height and width ratio as we did earlier, we'll take 20 divided by 2.35, and that's going to give us the height of our image based on the ratio 2.35 to 1. So here we have 20 to 15 at the aspect ratio of the television, and then 20 to 8.5, which is the aspect ratio of the 2.35 to 1 projected onto a 4:3 television. And again, you'll see the difference. We subtract these numbers here, we get 6.5 for the aspect ratio of the image and the aspect ratio of the television, and this is what both black bars is going to be equal to. So since both black bars equal 6.5, you divide that by 2 and you get 3.25 inches. So these black bars actually show up significantly more on the television because the 2.35 image does not fit the 4:3 television screen very good. So now we're going to take different devices. A sheet of paper is 8.5 by 11, the width to the length. Remember, the width to height ratio is the bigger measurement to the smaller measurement. So if we take an index card, the typical index card here is 5 inches to 3 inches, which means our aspect ratio is 5 to 3. If we were to convert that aspect ratio down to something to 1, all we do is we take 5 divided by 3. When we do 5 divided by 3, we get 1.67. The other type of rectangular object that I know very well here is a photograph, and a typical photograph where you're going to frame the photograph is an 8 by 10 photograph. So 10 inches for the length, 8 inches for the width. So here the 10 to 8 aspect ratio can be simplified to a 1.25 to 1 aspect ratio. The reason that we do the aspect ratio to 1 is so the division is very easy, and converting from aspect ratio to ratio of actual dimensions is actually quite a bit simpler. It helped us on the previous problems, and it will help us when we get on quizzes and tests. So next we have the idea of where a camera, most photography cameras are 4 to 3 aspect ratios. And we have several different size photographs for frames, etc. that we need to be able to make the image fit. So we take the 4:3 ratio and we try to fit in it a 4:6, which is also a 3:2 ratio. As you see here, it's simplified by a factor of 2. So here we have a bit of an example given for us, but we don't see how that example actually works. So many megapixels are wasted. 11% of the megapixels are wasted if we do a 4:6 photograph. But how do we get 11%? Well, the easiest way to do this is to find the aspect ratios as they are compared to 1. So 4 divided by 3 is a 1.33 to 1 aspect ratio. And 3 divided by 2 is equal to a 1.5 to 1 aspect ratio. Well, very simple. All we do now is take the bigger one and the smaller one on top, the bigger one on the bottom, and we have 1.33 repeating divided by 1.5, and we get approximately 0.889, which is about 11% when you subtract from 1. 1 minus 0.889 is about 11%. So that is how we get the 11%. Let's try this again. So let's take the 4:5 aspect ratio or picture size and the 4:3. The 4:3 again is a 1.33 repeating to 1 aspect ratio. The 5:4, remember, bigger size goes on top, divided by 4 is a 1.25 aspect ratio to 1. Well, the smaller number goes on top, the bigger goes on the bottom. 1.25 divided by 1.33 repeating. This gives us approximately 0.94, which, when we subtract from 1, is going to give us 6%. So clearly the 4:5 picture is better than the 4:6, because 4:5 gets to see more of the actual picture taken. We do this again. The 5:7. Remember, 4:3 is a 1.33 to 1 aspect ratio. We've done that twice. 5:7 is something a little bit different. We get a 1.4 aspect ratio to 1. Again, take the smaller one divided by the bigger one. 1.33 to 1 divided by 1.4 to 1 is approximately 0.952. Again, subtracting from 1, this is approximately 5% pixels wasted. So the 5:7 is even better than the 4:5 picture. The next one, I want you to look very carefully at the 8:10. If I was to divide each of these by 2, I would get a 4:5. And we have already done the 4:5 picture in the very first example after we proved how we got the example given, which means this is going to be a 6% waste of megapixels. And then we can do the 11:14. The 11:14, as expressed as something to 1, is 1.27. And so we take 1.27 divided by the 1.33 that we have done so many times before, and we get approximately 0.954. And again, this is very, very close to 5%. It's actually a little bit less than 5%. We could very specifically say it's 4.6%. So the best size picture to convert our photograph to from a 4:3 camera is an 11:14 photograph, because it wastes the fewest amount of pixels. The last thing we're going to look at is called the golden ratio. The golden ratio is the aspect ratio considered to be visually appealing. I am going to let you conduct research to figure out why the golden ratio is found appealing and why it is used so often. However, we are going to take these 4 rectangles and try to figure out which rectangle is the golden rectangle. So using our measurements here, we get a, looks like a 1.7 centimeters by 4.2 or 4.3. That's very hard for me to see. So 1.7 by 4:2. 4.2 divided by 1.7 is 2.47 to 1. So now we'll go look at the other rectangles. This rectangle looks to be 2.7 and 4.2. So 4.2 divided by 2.7 is a 1.56 to 1 aspect ratio. The next triangle, it looks to be 6.5 on the height and 1.5 on the width. 6.5 to 1.5 is a 4.33 repeating to 1 aspect ratio. And then the next one we have, looks like 1.8 by 5 centimeters. So 5 divided by 1.8 is 2.78 to 1. So here I took these measurements, and you'll see they're a little different because they are very difficult to read. And the golden rectangle is the second one here, because the golden ratio is approximately 1.62 to 1. So this one here is very, very close to the golden ratio. Alright, ladies and gentlemen, that is aspect ratios continued, all the extension questions to help you through any kind of project you might have dealing with aspect ratios.